Great. So, first of all, have you all received the homework questions, the document that I have sent to Gaurav sir? Have you all received it? Nobody received it?
Yes, ma'am.
Acha, you received it. So, how many people received that document? Okay, let me ask. Yashasvi, you got the homework questions with you?
I think, ma'am, no one received it. I forgot to update on app. So today I'll update it, ma'am.
Okay. No problem, sir. It's okay. Okay, all right. So, I couldn't find it. Okay, no problem. I didn't knew that आप लोग के पास नहीं आया. Okay, all right, no issues. So we shall continue today, and we can discuss like you can receive them today, and we will discuss the homework questions tomorrow because they are literally easy. Moreover, I have to make some some corrections in that because some things were not correct. So that will be good. Okay, all right. Now let us begin with today's class. So what I thought is, first of all, let us for some time just revise, what we learned because it was all the concepts was, like flooded in front of you. So you might all be very confused at what to do and what not to do. So simply let us take out 15 minutes and let us just revise the previous things. And now I want the full participation of everybody present here. So either I can pick somebody randomly to answer the questions or they can just come up voluntarily. All right. So I'm asking some things so that it may help you to revise whatever we have learned. And then we'll move forward with another concepts and then with questions. All right. So I'll be asking randomly right now because I don't think anybody will come voluntarily right now. Okay. So I'll be asking. Okay. Shifting of origin was one of the concepts that we read in the very beginning of the class, right? So I just want to know that how will we calculate, like if we have the x and y as the initial coordinates and x and y are the later coordinates, h comma k is the shifted origin, right? These all things we knew. So I just want to know, I'll just ask somebody randomly. So what will be the formula of this and what would be the formula of this in terms of this and this, in terms of the old variables and the shifted origin. So I'm asking this too. Let me see who are there. Okay, let us start from the beginning. Who's this? Mekala Ananya. And I'm so sorry if I'm pronouncing your names wrongly. I don't know actually. So Ananya, Mekhala Ananya, are you there? You can even text if you don't want to, unmute yourself. You can just text it in the comment section. Just text yes or no if you are there because so that we may move forward if you aren't present. This 1647971 Mekhala Ananya. Okay, I got this chat. Okay, so can you just tell me, either you can unmute yourself or you can just text that what will be the formula for this capital X and Y in terms of small x and y and the previous shifted origin. So can you just tell me this?
Ma'am, it would be something like x minus h and y minus k.
Okay, all right, Bharti. Okay, Chaitanya. Okay. I didn't knew. Okay, all right. You can just see what we are doing. It's okay. I didn't knew. And Chaitanya and I'm so sorry, my throat is not right today. And Bertie, well done. So we have, as you all said, x minus h and y minus k. Correct. Right? So capitals will be like the new coordinates will be old coordinate minus the shifted origin. Similarly, this. So simply we can find out what will be the value of the old origins if by chance we have to find out. So simply it will be the addition of these two. Right? So it is something that you should keep in mind. And you must not confuse in these two formulas. Either learn this or learn this. Right? So this was about the shifted origin. This was the first concept that we learned. So, Ananya, you can just see that what we're doing because today I'm revising whatever we have learned in the previous classes. Right? This was the very first concept. Okay. This was the very first concept, shifting of the origin. So whenever the origin is generally located at 0, 0 coordinates, but whenever it is shifted to some h, k coordinates, so the some point which is in respect to this this origin, it will also change with the shifted origin, and that is what we are finding out here, x, y. Right? Now moving ahead, we get slope. Interesting part. So slope. First of all, we know very like clearly that if a line is there and the angle which it makes with the positive x-axis, like this is the positive x-axis, right, and this is the line. So this angle which it is making with this line, the angle which this line is making with the positive x-axis is known as a theta, and the slope of this line, if we have to calculate the slope, it would be m, like it is denoted as m, and it will be tangent of theta, right? Tan theta. So this is about slope, like this is the definition of the slope. Tan. Okay. Correct. Right. And moreover, we got to know one more thing, that if we are taking the angles between 0 and 90 degree, like obviously we know that angle theta between 0 and 90 degree. So we can just write it like 0, theta, 90 degree. So whenever this is the case, we know that the angle is known as acute angle, right? And in this particular case, tan theta would be positive, right? And if we are taking the angle between 90 degree and 180 degree, which means like this, so the angle is somewhere between these two. So definitely it is known as obtuse angle, right? And in that particular case, tan theta would be negative. So this is one thing that we got to know, right? So these two things are very important, because by chance you do mistake with the signs, it may ruin your answer. So you must know that whenever the angle is acute, tan theta will be positive. Whenever the angle is obtuse, tan theta will be negative. Okay, we have some chat here. Right, Varti, absolutely correct. Okay. So this was about the slope. Moving ahead, what we learned next, like these were things that you might have learned earlier as well. We're just brushing up them so that somebody who is new or somebody who has forgotten them, they may just recap it. Then we knew then we saw some like equations of the line, like y minus y1 is equals to mx minus x1. Right, so from like this, actually what we were doing here, we were just calculating the value of the slope. So why this, that we got this equation, so we can see two things here from here, that see this m, it is a slope. So whenever in the question we have to find the slope, then we'll use this formula definitely, right? But whenever in the question we have to find the equation of line, so we'll use this, right? So it depends what we have to find out. Accordingly, we'll just manipulate, or we'll just modify the formula and we'll get the result. So if we have to find the slope, we'll apply this formula where this x1 and xy1 are the coordinates of the point which are known to us. Like it will be given in the question, like 2, -3 and so on. But x comma y, which is written in general, right, if coordinates are given, definitely. So this x1 comma y1, these are some coordinates of a point which are given to us in the question. For example, 2 comma -3 is given in the question, right? And if we have to calculate the slope, so we can find out in this way. But here only one point is given. Definitely we can see that only one point is given. This x comma y is general. Like we will not keep any value of this x comma y. We'll just keep them as it is, and we can find the value of slope. Or if we know the slope, we can find out the coordinates if some more information is given. But if we have to find the equation of line, where sometimes we have to find the equation of the line, then we'll use this particular equation. It's just, we just kept it here and moved it here. It is just that. But then too, if we have to find the equation of line, then we'll use this slope. For this, we'll use this, right? So this was something related to slope. Moving ahead, one more very important thing that we got to know in the last classes. Oh, sorry, 1 second. One more important thing that we got to know was this. Like, see, if we have to find out the slope, we don't have to follow the long procedure because it may waste some minutes of us, and we cannot afford to waste time. So simply, it is whenever we are supposed to find the slope. So if an equation is given in this form, general form, right? Or in a way where we have got the coefficients of x and y intact. So there we can do this. Simply, if we'll find out what is the coefficient of x divided by what is the coefficient of y, right? And multiplied with this minus. So we'll get the value of slope. For example, if we have got 3x plus 4y minus 6 is equals to 0, for example. So what we will get the slope as? Who will tell me? Yes, correct. -3/4. Absolutely. So it was that easy that I asked, and he said that because we know that we can just apply this formula and we'll get the slope. We don't have to follow the long procedure if there is any, right? So this was about the thing that we can remember. Like it is a short trick sort of thing. This is derived from the long part, so we can use this. Moreover, angle between the two lines. This is very interesting part. Angle between two lines, right? Angle between two lines. So tan theta, tangent of that theta. This theta is the angle between the two lines. So definitely we don't have to do anything with the theta alone. What we will do of it, but we'll have to do something of this tan theta because we have to find a slope, right? We are generally interested in the slope, then the angle. So who will tell me the formula? Somebody? I want the exact correct formula. I don't want
Plus or minus.
Sorry?
Plus or minus m1 minus m2 by 1 plus m1 m2.
Okay, so what will come initially? Like M2 or M1?
M2.
Right, correct. Very nice. I'm glad that you people are revising. Very good. Absolutely. So this is the perfect formula. See. One very important thing. If you are writing plus minus, and this is the exact correct formula, don't just write either plus or minus. This is the correct formula. So just remember that you cannot write M1 when you're writing plus and minus, because it will change the whole formula. The right formula is in this format: plus minus M2 minus M1, because if by chance we have to deal with the minus, then it will be, it will be done accordingly, M1 minus M2. And if we have to deal with the positive, then it will be exactly correct, M2 minus M1. Don't change it to plus minus M1 minus M2, because it can ruin the whole formula and it will ruin the answer also, right? So this is the exact correct answer. what we are doing here, why we are applying, why we're putting this plus and minus here, because see, whenever what will be the value, like what will be the sign of tan theta, it will be positive when theta is acute. Whenever theta is acute, like it is, if it is given in the question, if the theta is acute, then the tan would be taken as positive. Then we'll take this positive sign. So what will be the formula this time? If the theta is acute or it is between 0 to 90 degree, it would be m2 minus m1 divided by 1 plus m1 m2, right? m1 into m2. But if we have got, sorry, I'm so sorry. But if we have got theta is obtuse, then tan theta would be negative, right? And then what we'll take is the negative sign along with the whole formula. So what, how will it help, this negative sign? It will help to convert this part because it will remain intact. There will be no difference in this 1 plus m1 m2, right? But it will become m1 minus m2, 1 plus m1 m2. So it will be absolutely correct then, right? So that is why it is for this condition, this is for this condition. So thus we got to know that the correct formula, like the exact formula which has both the conditions in it, is this one, plus and minus m2 minus m1 divided by 1 plus m1 m2. So this was the thing that we discussed in the last class again. Sorry, last to last class. Angle between two lines. So if we have to find the angle between two lines, if it is given to us, then we are mostly interested in the tangent of that theta, which is the slope. And here we have got the formula. So whatever are the slopes of those two lines, the equations would be given to you most probably. So you have to just find out the m1, m2, and you have to put them here accordingly. Like if theta is acute, then put in that. If it is obtuse, keep in this, and you'll get the value of tan theta in which you are interested. So basically this tan theta is m. So you'll get to know that m is equals to this or m is equals to that, right? Moving ahead, we saw the various forms. Oh, sorry. Various forms, right, of line. Okay. Tan theta, definitely Janvi, and verti like slope. Sorry, I didn't got you. Like slope means? Okay, this theta thing, that if it is acute, then we'll take it as positive, and if it is obtuse, then we'll take it negative. Like this. I think you are telling in that respect, sorry. Okay, you can just type. Till that time, I'll move forward. Various forms, right? Various forms of line. So we saw some forms, and now I'll ask, like I'll pick somebody randomly. So don't come up voluntarily. I'll ask from somebody and they have to tell. Okay. The first one is slope, and nobody will write. Don't type, right? If you know, it's all right. If I'll ask you, then only you have to tell. I want to see how many people are like revising. So don't type and don't answer. I'll just ask. So first of all, there is slope point form. Definitely by the name, as I suggest, you must have got the m and some point here. So let us take it at x1 and y1. In this formula or in this form, you have got both of these things. So which form is this, and how can we write it? Let me ask to somebody. Okay, this is the first class of Ananya. Arya, can you please tell me?
Yes, ma'am.
Okay.
Y minus y1 is equals to m into bracket x minus x1.
Okay, correct. 100 out of 100. So this is the slow point form. Very important, right? This was the same that we saw in the upper part as well, that if we have to find the equation of line, when these two things are available, so we have to find like this. And from here we can say that we can also find the value of slope. It will be y minus y1 upon x minus x1. So just the slight changes in the formula and you will get different things, right? Next one. Good, Arya, very good. Next one is 2 points form. Don't get confused in these forms. I definitely know that these are slightly confusing. You might get slightly confused, like which one is which form, but don't get confused. Just keep seeing what is being given in the form. 2 points. So definitely you got to know that there is no slope available, like m is not present at all. 2 points, which means two coordinates are given. The coordinates of 2 points are given, which is known to us. So accordingly, you have to search the formula that is there. Okay, Bharti has raised hand. Okay, you can tell Bharti.
Yes, ma'am. It will be y minus y1
Hmm.
equal to y2 minus y1 upon x2 minus x1
Hmm.
x minus x1.
Okay, 100 out of 100. Very good. So again, this was very correct. We got to know that we are available with some coordinates of 2 points, 4 coordinates for 2 points, and we are not given m, so definitely we'll not write it, right? Well, there is m hidden in this because we definitely know that y minus y1 divided by x minus x1, if we bring it here, it will be m only. But here, why we are not keeping it in that way? Because we don't have it, or we don't require it, moreover. Because if 1 point is given, and like if a 1 point is given, so we can find out the equation of the line. And if one slope is given and the 1 point is given, then we can find the equation of the line. Or if 2 points are given, 2 points which are, or they're on the same line, if they are given, then there is no requirement of the slope. So accordingly, we can adjust. It's just that how, like in which form we get the question, it depends on that. Okay, very good. Next one is intercept form. Intercept form. So definitely now, by the as the name suggests, intercept, which means it will include intercepts in it. There is no scope for any other thing because there is not written, right? So now think of this form and don't see in the register. Just try to, you know, memorize it. So don't see in your registers, like don't see in your notes. Just try to memorize what we are trying to say. So intercept form, it will include the intercepts, right? So you definitely know which are the intercepts. But yeah, I appreciate, but let us ask from other participants as well, because they might get benefited from that. And definitely you might know it, I'm sure. Okay. So I ask the next question to Chaitanya. Chaitanya, can you please tell everybody what is the intercept form? No, I'm asking to Chaitanya. Chaitanya, are you there or are you typing? Just like write yes or no or something. And I think he wrote also, like, so he must be present. Initially, right, Chaitanya? And you can just unmute yourself as well. There is no, like, need of writing. Okay. Ma'am, I would not remember. Okay, no problem. It's okay. All right. So, Meghna, no, right? So I'll not ask her. Definitely. Let us ask some other people. Deepti.
Ma'am, by a plus y by b equals to 1.
Right, very correct. 100 on 100 to you as well. So yes, we have this form for intercept where A is the intercept, like A is the x-intercept, so it is beneath x. So sorry for my throat. And okay, and B is the y-intercept, which is beneath y and is equals to 1. So definitely we can see that there is no other thing like slope, no point, no coordinates, no nothing. We just have the intercept. So Chaitanya, have you remembered it now? Like, is it okay? Just learn it here now. I may ask you at the end of the class. Okay, so just remember this. Okay, cool. Moving ahead, one more form that we read was parametric or distance form, right? Parametric or distance form. Let us see. So who will tell me this? He'll get 105 out of 100, and without telling, mind you, you have to be honest on your side, right? Who will tell me, who remember this particular one? He'll get 105 100. Who's that person? Just raise your hand.
Can I, ma'am?
Yes.
X minus x1
Hmm.
upon cos theta
Hmm.
uh, is equals to y minus y1
Hmm.
upon sin theta
Hmm.
is equals to distance r.
Okay. Right. Very good. Who was it? Meghna?
No, ma'am, Arya.
Oh, sorry. Arya. So, Arya, you get 105 out of 100 because this is very, very correct. And I hope that you weren't seeing it. So, it's very, very good. Yes. So, this is the parametric or the distance form. And here, definitely, we can see that, see, either we will be, set to find out theta or r. So, it depends. Like, some information will be given to us, some information will be asked, right? So here we have x and y. X and y is there generally in everything. X1 and y1 are the coordinates of the point. Theta will be the angle that the line will be making with the positive x-axis, and so, right? So we'll just keep the value of theta, we'll just keep the value of the coordinates, and then we can find out the value of, like, what is the distance. So we can calculate the value of r. So this is the parametric or the distance form, and very good, Arya. Ma'am, can you explain parametric form? Okay, I'll do this. Okay, let us do one thing. There are only 4 things to revise. I'll just quickly revise them and then I'll come to this. Is it okay, SSV? Like only in 5 minutes we'll come to this. Okay? Okay, let me see. Okay. So just quickly, we are taking 4 more things that we learned. The next thing is normal form. So, normal form. Who will tell me this? Let me ask. Who's there? Janvi Mishra. Can you please tell us the normal form?
Yes, ma'am.
X
cos alpha plus y sin alpha equals to p.
Cool. Very correct. So here, this alpha is the angle. So here we know that if there is the Cartesian plane and here's a line like this, it is a line, the equation of which we are finding out, right? From the origin, a perpendicular is dropped upon this, right? So this distance of the perpendicular from the origin to this particular line is P, for suppose this P, and the angle which this perpendicular which has been dropped on this line, it is making with the positive x-axis, it is alpha. So whenever such situation arises, what you have to write the equation of this line as x cos alpha plus y sin alpha is equals to P, right? So this is the normal form. Okay, correct, very correct. 100 on 100 to you as well, Janvi, right? And the next thing is, okay, now look, one thing is very important, and I don't remember that whether we have taken it or not. But then, even if we have not taken it, then too, I'm telling you. See, definitely, we can use this particular formula to tell the equation of the line, right? But if sometime, or if like any time, we have to find out the value of this p, which is the perpendicular distance which like this origin has, like from origin this perpendicular has been drawn to this line. So how can we find out what is the length of this line, right? So what is the value of p? So sometimes we might be asked to find out p first of all, and then we will be able to keep the value in this equation and find the equation. So how we are going to find out p, like what is the formula for it, right? For example, if it is m, and if this point is n, if this point is m and this point is n, so what will be the value of mn? So I'll just write it, you all can see. Mod of ax1 plus by1 plus c divided by under root of a square plus b square. This is the perpendicular distance from the origin to the line which is drawn. So ax1 plus by1 plus c divided by under root of a square plus b square. Now don't get confused at what is it. If somebody doesn't know, we'll take questions on it, and it will be clear to you. I'm just telling this. This is the formula where x1 and y1 are the coordinates. So we'll just keep the values of the coordinates in that particular general form of the equation. And here we'll just find out the square root of the sums of their square, right? So this is the way in which we can find out p, and this p we can keep it here so that we can find out the normal form, right? So this was an information. I don't remember whether I told you this or not. And who will tell me the general form? Anybody? Or shall I ask? Okay, let me ask only. Manish, can you tell us the general form, please? It is very simple. Manish, are you there? Just type or just say something. Okay, so I think he's not here. Okay, no problem. Shivang, general form. Shivang, are you there? Meghna, I'll ask you. Just a second. Oh, am I not audible?
Audible, ma'am.
So Shivang, am I not audible to you? Or you can just text it. It's very simple. Okay, no problem. Okay, so we'll ask to the girls only. They are very eager to answer, everybody. Okay, Meghna, I think you raised your hand, right?
ax plus by plus c is equal to 0.
Sudarshan. I'll ask you the next one. Okay, so very good again, Meghna, 100 out of 100. This is very correct. And Shivang, if you're listening, that's very bad. You're not replying. This is very simple. Like, this is the thing that comes initially. Very bad. And the girls are replying very eager, like enthusiastically. Good. The last one is slope intercept form, and I'll ask to the person who raised the hand. I think Sudarshan. You can just tell me. Slope intercept form. What is it? Very important. Like, it is the most important thing that we have like learned. So tell me,
Ma'am, I'm Sudarshana.
Oh, sorry, Sudarshana. Oh, I thought something else. Okay, tell me.
Y is equal to mh plus c.
Correct, very good. And it is the most desirable form. So you must all remember this, and well, all are worth remembering. Okay, all right. So this was all about what we studied in the previous classes, right? All these forms, all these slopes and all, and the shifting of the origin as well. So I think that till here, nobody has got any doubt. If somebody has got any doubt, they can just tell me. But we have done, and we have also done some questions on each of these questions in different forms. So I hope that it might be slightly clear to you that what we have to do. So is there any question to anybody here, participants? 22 participants, like 20, except Gaurav sir and me. Chat. Ma'am, NATA previous year question. Oh, right. So, Bharti, I received one PDF from Gaurav sir. He sent me one. And in that, I didn't find any question of straight line. One seemed to be that of straight line, but it wasn't. So, I didn't got any previous year question which was off straight line. Like, I got the question paper, but that didn't contain it. And oh yeah. Okay. Sorry, I just forgot. Yes, Yashasvi, I'll take it. So please, anybody, if you have got the previous year question paper, and moreover, I would like you to just crop the straight line question. Like you definitely know which one will be the of that of the straight line. So don't send the whole PDF because like you can send it, but if you will send the cropped question, it will be more easy to like concentrate on it. So you can just forward it to Gaurav sir and he'll just convey it to me, right? Because I didn't find till now any question which was
Ma'am,
there.
even I did not find any that kind of like these using these formulas. No question was like that, but there were questions like a particular person wants to go from one place to another, and he has traveled some distance in different directions. So what would be the shortest distance he has traveled? So in those kind of questions, we just have to find the straight line so that we can get the shortest distance.
Okay. So whichever type of questions are available in the previous year question paper of that of straight line, which you think are of straight line, if they are using these formulas, all right. If they're not using it, all right. Because we just have to explore more and more about this, right? So I have this content, like I saw the syllabus and I brought the content. But definitely, if the questions will require some additional information, I'll try to search it out and tell you. So anything, like any question which you get, and you think that it is of straight line, you can just crop it and send it to sir. You can just make a PDF of all the questions combined and like that. So it is not compulsory that they should contain all these formulae, like they should be answered through these formulas. They can be like anything, but they should be a straight line topic particularly. So just send anyhow you can just tell them to me, or I'll take one of your number, like a Varti or somebody from sir, then I'll just communicate with you directly so that there will be no problem, right? So you can just tell me whichever questions are there, because see, I don't know how which type of question are generally come. So that, for that I have to get an idea, but I didn't get any idea till now. So are you getting my point? So any question you feel that it is a straight line, you can just tell or convey to me. Okay.
Okay, ma'am.
And moreover, one more thing, that if you'll ask like the question that whatever is there in this class or in the particular class that is going on, it might be slightly difficult for me to answer it right away, because these concepts are slightly, unrevised for me. So I have to revise them myself and then I teach you. So if, just tell me whatever questions are there one class ago, like one day ago, so that I may research on it and I can get the foolproof answer for you.
Okay, ma'am.
Okay. So, all right. Moving ahead, I hope that if you find the answer, find the questions, you will send it to me. Moving ahead with the topic that we were doing, Okay, now 3x. Oh, sorry, again I forgot. So sorry, Yashasvi. Oh, I'm so sorry. I was almost, I like almost forgot. Parametric form. Parametric form. So sorry. Let me try to explain you the parametric form. So see, there is not much to explain in this because we are not going in very depth of it, because it is not of that use as well. It is slightly uncommon. So I am just telling you whatever I told in the lecture previously, because there like beyond that there is no need to tell. So parametric form or the distance form. Here we have the Cartesian plane, right? Here we have water line. Now what is happening here? Say for instance, this particular point on this line, this point on the straight line, its coordinates are x comma y, right? And there is one more point on the same line which is here, whose coordinates are x1 comma y1, right? X1 comma y1. So here it is x comma y, here it is x1 comma y1, and this particular coordinate are known to us. Like it will be given, its value will be given 1 comma 2, 2 comma 3 or so on. Okay, like 3 comma 2 or whatever, it will be given to us, but this is not given to us. So these 2 points are given to us on this straight line. Till here, is it clear, Yashasvi? You can just keep typing yes, so that I'll get to know that you're right, like getting it. Okay, now look. Now look. Now what we are trying to do. See, what we are interested in is this angle. In this angle, right? In this angle we are interested. So what we did, here was a line, these points were there, we just connected in such a way that there is an angle between these two, like this theta exists here. Now we are interested in this theta, and in the parametric form, like whenever you read the parametric form, this name parametric, this deals with the sine and cos, like sine and cos of the angles. But here there is no such use of tangent like slope. Here we are interested in some different thing, right? So it might you might say that parametric form concerns generally with the sine, the cosine cosine of the angles. So what we are interested in this theta, because to find sine and cos, definitely we will have to find the value of theta first, like what is theta or how it can be defined. Now we know one more thing very one more thing is there, that the distance between these 2 points, like this distance, here is this point, here is this point, and the distance between these 2 points is r, small r, right? Now, in order to find out this theta, we definitely know that this angle which it is making here is 90 degree. This one, this is theta. Okay. So now if we have to find out the theta, so definitely we have to find these 2 things as well. We have the hypotenuse with us. The angle, like the side which is in front of the right angle, is the hypotenuse. So we just have to generalize that what are these two distances, right? So we definitely know that what are these. For instance, if this part is y, we can see that this particular part is y. This. Okay, so this particular length is y, and x is this coordinate. So we can see that this is x. Similarly, we can see that this is y1, and if we talk about the x coordinate, so here something, it will be x1. So what do we got to know, that this thing, this particular length or this particular distance would be x minus xy. X minus xy. We have to find out these two in order to find out the theta, right? Then we have to find the sine theta. So this is very important. X minus x1 will be equal to this region. Similarly, y minus y1 will be equal to this region, what we need to find here. So till here, is it clear? Or shall I explain once more? Till here, how we found out these two things? We're just finding out the remaining distances. Yes or no? Yashasvi? Okay. All right. So till here, if it is clear, then definitely we can say from here, just we can figure out that from here, see this triangle, if we have to find out the cosine of the theta, right? So it is what? B upon H, which means base upon hypotenuse. So it will be it will be x minus x1 upon cos theta. Oh, sorry, sorry. Not cos theta. X minus x1 upon r. Similarly, if we have to find, so from here we can we write it like this, that if this particular thing is cos theta, so x minus x1 would be equal to r cos theta, right? We have just changed its position. Similarly, if we have to find out the value of sine theta, it will be perpendicular upon hypotenuse. So it will be y minus y1 upon r, which means it is sine theta. So we can find out the value of y minus y1 from here, and in the form of, like, in terms of r and sine theta, right? So this thing is, again, I think, I suppose clear. Some chat is there, 1 second. Yes, I got it. Okay, well, it's fine, but then too I'll just write whatever is remaining. So we can see one thing is common in these two formulae. See, this particular thing is all right. This is also all right. There is no problem in this. These are correct. But to generalize it further, and we know that this r is common, so we'll write it in terms of that. X minus x1 upon cos theta is equals to y minus y1 upon sine theta is equals to r. So we are just writing it in this form. And this is the parametric or the distribution